All right, a box containing a new bookshelf that's not assembled with a gravitational force of 300 newtons moves with a constant velocity across the floor when it is pushed with a force of 450 newtons exerted downward at an angle of 36.6 degrees below the horizontal. Find the coefficient of kinetic friction between the box and the floor. Step 1, draw a free body diagram. So the floor is going to be horizontal, so we're just going to draw a nice horizontal line for our surface. And I'm going to go ahead and place a dot on that line to represent the box. So the first force we check for is the gravitational force. It even tells us what the gravitational force is, but of course a box of books or a box of a bookshelf is going to have a weight or a gravitational force. And then if there's a surface, there's a normal force, which is perpendicular to the surface. You need to make a 90-degree angle with this surface, which means I'm going straight up in this case. And then it says it's being pushed with a force of 450 newtons, exerted downward at an angle of 36.6 degrees below the horizontal. So I'm going to push it down and to the right, okay? So I need to go 36.6 degrees below the horizontal. So this is a horizontal line. I need to go 36.6 degrees below that. And this is the force we're pushing with, so this is the applied force. Okay? And then my last force, of course, since it's sliding along the floor, we've got some friction. And since it is moving, it is kinetic friction. So we got our picture. Next, we want to write down our givens. The one thing it says is the gravitational force, so Fg, is equal to 300 newtons. This is a little different. Last couple of problems, they gave us the mass. We had to find Fg. This time, we just know Fg from the beginning. It's going to be moving with a constant velocity. That's important because that tells us it's in equilibrium. Okay, so later on, we'll know it's in equilibrium. When it's pushed with a force of 450 newtons. So the applied force is 450 newtons. Find the coefficient of kinetic friction. So we're looking for mu sub k, the coefficient of kinetic friction. There's only one equation that has the coefficient of kinetic friction in it, and that's the force of kinetic friction equals the coefficient of kinetic friction times the normal force. I look at my givens, I don't have the force of kinetic friction. I do not have the normal force. So I'm going to need to find those. Our hint is, if we're in equilibrium, we can use our two equations that say that the net force in the x direction is 0 and the net force in the y direction is 0. Now, things are a little bit different this time. In the x direction, I go and look. I want to say that the left forces equal the right forces. So I go to look. Well, pointing left, we have the force of kinetic friction. Great. Pointing to the right, not all of this applied force is pointing to the right. It's pointing down and to the right. Some of it is going to the right, and some of it's going down. I need to find the component of the applied force that is going to the right. Okay? And then later on, we'll need to know the component of the applied force that is going down. Okay? So we can call these whatever we want. I'm going to call this the force in the x direction because it's in the x direction, so it's the x component of the applied force. I'm going to say that this is the x component. And now I know how to solve for these two sides using trigonometry. I know that the applied force, this blue line, is 450 newtons. So I can label my sides. This is the hypotenuse. This would be the opposite of the 36.6, which means this is the adjacent. If I'm looking for the force, the component in the x direction, I'm going to circle the two numbers and then go ahead and look. I've got the adjacent and the hypotenuse. So in my memory aid, SOHCAHTOA, I've got A and H, so I'm going to use cosine. Go ahead and say the cosine of the angle, 36.6, is equal to the adjacent calling that have the cosine of 36.6 equals the adjacent over the hypotenuse, which is 450. Multiply both sides by 450. We get the x component is 361.27 newtons. We could have called this anything, and you'll notice in some of our problems, I call this the parallel components. It's a symbol for parallel from your math class, okay? Because it's parallel to the direction of movement, okay? But we really can label them as whatever we would like, okay? It's just a label. All right, so now I'm going to substitute in. I know that the force of kinetic friction is equal to the component in the x direction, which I just found, is 361.27 newtons. Next, we want to find the normal force. And the normal force is in the x direction, or sorry, in the y direction. So we're going to look at the net force in the y direction to do that. So when the net force in the y is 0, that means the up forces need to balance the down forces. So we look at our picture. Pointing up, we have the normal force. And pointing down, we have the gravitational force. And students often overlook this, but we also have a component of the applied force, which we need to pick something to call it. I'm going to call it Fy right now. You'll notice sometimes I call it the perpendicular component. We use the symbol for perpendicular from geometry. I'm just going to call it the Y component of the applied force for right now. Again, it doesn't matter what we call them, okay? It just matters if they match the picture. So, the normal force, well, we don't know it. The gravitational force, we do know, is 300 newtons, plus the y component over here. So I have to find that. So I circle this, I circle my two numbers, and I notice I circled opposite hypotenuse. I'm going to use sine my trig function. So I will say the sine of 36.6 is equal to the opposite, which I'm calling the y component right now, over the hypotenuse of 450. Multiply both sides by 450. The y component is 268.3 newtons. So 268.3 newtons. And now I can find my normal force by adding those two together. So I get 568.3 newtons. Okay, the normal force needed to balance the gravitational and the applied. It balanced both of those, that's why it's bigger. Now we're ready to go ahead and solve. We have everything we need. So substitute in. The force of kinetic friction is 361.27 equals the coefficient of kinetic friction times the normal force is 568.3. Divide both sides by 568.3. And we get the coefficient of kinetic friction is 0.64. We rounded 2 decimal places. Okay, so this was a little different than before because this time we have to find the components, and then in the x direction there were 2, but in the y direction there were 3 forces or components of a force. Okay, so it's a little bit different.